The days of just swiping a credit card for the smartest AI model are over. Welcome to the era of geopolitical gatekeeping, multi-billion-dollar silicon wars, and government-cleared cloud zones. Yeah, I mean, the landscape is just fundamentally fractured. The strategies that worked for technology executives even, say, 6 months ago, they are now functionally obsolete.
Right. Well, welcome to AI Coffee Table Conversations. For today's deep dive, we've got a one-line teaser for you. We are covering the government gating of GPT 5.6, Qualcomm's $3.9 billion assault on NVIDIA's software lock-in, and OpenAI bypassing everyone to build its own custom silicon.
Exactly. And our goal today is to just, cut right through the hype. We want to separate what is a real structural shift from what is just market noise.
Yeah.
We're giving you actionable intelligence on whether to act now, watch, or just ignore these trends. We're looking at all of this strictly through the lens of long-term organizational resilience.
So let's unpack this first major shift because it really flips the script on how you even access artificial intelligence right now.
It really does. So June 26, 2026, OpenAI officially unveils its next-generation model family, GPT 5.6. And they structured it into three distinct tiers. You've got Sol, which is the flagship, Terra is the balanced tier, and Luna is the fast option.
Right.
And the capabilities are wild. We're looking at benchmarks where Sol's Ultra Sub-Agent hit 91.91% on Terminal Bench 2.1.
Which is huge.
Yeah, it's a brutal command line automation test. And it just actively beat Anthropic's restricted Claude Mythos 5.
What's fascinating here is that the real story isn't actually the benchmark.
Right.
It's the unprecedented government intervention that happened on launch day.
Yeah, the Trump administration and the Office of the National Cyber Director basically stepped in.
Exactly. They stepped in and mandated that OpenAI restrict the rollout of this flagship model due to, acute national security risks, specifically advanced cyber capabilities, and dual-use biological and chemical reasoning.
Which is a mind-blowing paradigm shift.
Yeah, we are witnessing a major pivot toward state-supervised commercial software. As it stands right now, only about 20 pre-approved enterprise partners are getting access to the Sol tier.
Only 20.
Yeah, federal agencies are vetting access customer by customer.
And to understand why the government is so terrified of these models just sitting on public APIs, you kind of have to look at what just happened with Anthropic.
Oh, the distillation attack.
Right. They accused Alibaba's Quen lab of this massive distillation attack.
Yeah.
Where you basically use an automated script to systematically map out and steal a smarter model's underlying logic.
And the scale of that operation was staggering. Alibaba allegedly deployed nearly 25,000 fake accounts.
Jeez.
Yeah, to generate over 28.8 million exchanges with Claude. They were actively trying to extract Claude's advanced reasoning to train their own internal models.
Okay, let's unpack this. So is this like trying to buy weapons-grade plutonium now instead of just a software license?
Pretty much, yeah.
I mean, if the regulatory hand is visible on launch day and the government can just say no to your access based on shifting guidelines, how can any IT leader actually plan a product roadmap? You could be building this complex agent workflow around the Sol model, and suddenly, boom, your access is revoked.
Well, the capabilities of GPT 5.6 are substantial, but the hype is assuming these models will be democratized for general enterprise use. That's pure fiction now.
So the democratization just isn't happening.
No. The regulatory bottleneck is highly restrictive, and it's likely a permanent boundary. If you're an IT leader, you have to stop waiting for Sol.
Pivot to Terra, I assume?
Exactly. Pivot your development to the Terra tier immediately. It delivers roughly GPT 5.5 level performance at half the token cost. And crucially, it's far more accessible.
Right.
But you also have to prepare for a massive infrastructure markup. Organizations are going to have to run these models inside cleared cloud zones like AWS GovCloud or Azure Government. You should anticipate markups of 2 to 3 times standard cloud rates.
Wow. 2 to 3 times the cost is going to absolutely obliterate some IT budgets if they aren't planning for it right now.
Oh, absolutely.
So if you're building abstraction layers to avoid being locked out of an AI model by the government, you also need to ensure you aren't locked into the hardware running it. Which brings us to the second massive shift.
The hardware lock-in problem.
Exactly. Qualcomm is trying to blow this wide open. On June 24, they announced they're acquiring Modular Inc. for $3.92 billion.
Small stock deal, yeah.
Right. And for those who aren't deep in systems engineering, Modular created the Mojo programming language and this thing called the Max engine. Usually you have to speak NVIDIA's specific language, CUDA, to use their chips.
Which is a huge bottleneck.
Yeah, but Mojo acts like a real-time universal translator. You write your AI stack once, and the Max engine translates it on the fly into whatever native language the underlying chip speaks.
Mhm.
CPU, GPU, NPU, whatever.
And this targets the most expensive moat in the enterprise. NVIDIA's CUDA software has created this 20-year moat, forcing companies to buy NVIDIA chips because the cost of rewriting your software for, say, an AMD Instinct is just prohibitively high.
And this is part of a much larger ecosystem play by Qualcomm, too, because they're also in advanced talks to buy the RISC-V startup Tenstorrent for roughly $8 to $10 billion.
Yeah, so you combine Modular with Tenstorrent, and you're looking at a $14 billion full-stack alternative to NVIDIA. This brings serious bargaining power back to the IT department.
I have to push back a little here, though, because, well, I've heard this CEDA killer hype before. Every few years, someone claims they have the magic compiler.
Sure.
Isn't relying on a magic compiler abstraction layer just asking for edge case disasters in production? Plus, what stops Qualcomm from just tweaking this open compiler to favor their own NPUs down the road?
That skepticism is entirely warranted. The portability is substantial. It genuinely runs on NVIDIA, AMD, Apple Silicon. But thinking NVIDIA's market dominance simply evaporates overnight, that is pure hype.
Right.
CUDA's 20-year moat is incredibly deep. Transitioning existing production pipelines will take years of deliberate tooling. And yes, the strategic risk of Qualcomm favoring its own hardware is very real.
So if a full transition is going to take years, what's the immediate next step for you if you're listening to this?
Start with a thorough organizational audit today. Identify exactly where your software dependencies are locked to NVIDIA CUDA or AMD ROCm frameworks.
And then run some experiments.
Exactly. Task your systems engineers to run exploratory pilots with Mojo on non-critical inference models. Start building that institutional muscle for hardware flexibility now.
Build the familiarity on the non-critical stuff first, so you have leverage when you negotiate your next cloud contract.
You got it.
I like that. But here's where this hardware conversation gets really fascinating. Qualcomm is spending billions to abstract the hardware, but the AI labs themselves are realizing that to survive, they need to physically build the hardware from the bare metal up.
The vertical integration of inference?
Yes. Let's talk about Jalapeño. This is OpenAI's debut custom inference chip, co-designed with Broadcom, manufactured by TSMC on a 3-nanometer node, and it went from concept to tape-out in just 9 months.
Which is incredibly fast.
They're deploying these in gigawatt-scale data centers by late 2026.
And this just highlights the sheer scale of the infrastructure and talent war going on. While OpenAI is rushing to build silicon, the broader market is in absolute chaos. I mean, Google DeepMind just lost its Nobel laureate, Dr. John Jumper.
Right, he defected to Anthropic.
Yeah, along with top Gemini leads. And that wiped $225 billion off Alphabet's market cap.
It's just insane.
It is a ruthless war for human capital and for metal. Amazon is spending an additional $13 billion, bringing their total to $48 billion by 2030 just on Indian data centers to push their own Trainium chips.
So why are they spending GDP-level money on this? The big signal here is that AI commercial viability is no longer about training. It is about inference.
Running the models, yeah.
Exactly. Jalapeño is an ASIC, an application-specific integrated circuit. It optimizes memory movement specifically for transformer kernels, lowering OpenAI's reliance on NVIDIA and allowing them to slash API prices in a price war. But again, let me play devil's advocate. If they hardwire a chip specifically for today's transformer architectures, isn't that like paving a custom highway that only fits one specific car?
Oh, absolutely.
If the industry discovers a radically better architecture tomorrow, doesn't this multi-billion-dollar Jalapeño chip just become an expensive paperweight?
That is a brilliant analogy. The engineering is real, but the capital depreciation risk is severe. Custom hardware can absolutely struggle to adapt to fundamental shifts.
Right.
And the hype assumes this chip solves OpenAI's compute bottlenecks immediately. In substance, volume production won't really hit until 2027, and TSMC's supply chain is heavily constrained by Apple and NVIDIA anyway.
So the availability of bottlenecked. Given that, how should an IT leader recalibrate their strategy based on this?
Recalibrate your multi-year AI operational budgets right now. Project a 50% decrease in API token costs by late 2026.
Half the cost. That changes the entire math.
It does. It means you should start designing run-heavy agentic workflows today. Look at Anthropic's new Claude tag for Slack.
where it operates in that ambient mode.
Exactly. It just ambiently reads channels and executes asynchronous tasks.
Mhm.
Under current GPU pricing, that would bankrupt a department.
Paying by the token for an AI to constantly read a 50-person Slack channel.
Terrifying bill, right.
Yeah.
But with custom chips driving costs down, ambient AI teammates become standard. Or their new Claude Code artifacts, where the compute to run continuous interactive systems is about to become drastically cheaper.
Okay, so bringing this all together, we've covered the government gating of frontier models, Qualcomm breaking the software dominance, and OpenAI vertically integrating inference chips.
A lot of ground.
Yeah. So what is the single most important thing IT leaders should do this week?
Treat foundational models as swappable API endpoints, period. Implement clean abstraction layers immediately to protect your applications from sudden regulatory bans or vendor hardware lock-ins. Flexibility is your only true moat.
Flexibility is the moat.
And I want to leave you with a final lingering thought to ponder.
Go for it.
As the government strictly gates flagship models, and as custom silicon becomes the only affordable way to run them, are we heading toward a permanently fractured enterprise landscape? Think about it. Will there be an elite, cleared tier of companies running ultra-automated businesses on custom chips, and then a second tier of everyone else just stuck waiting months for watered-down public APIs?
That is a sobering question. Which side of the gate is your organization going to be on? Well, that wraps up today's deep dive. Treat those models as swappable, build your abstraction layers, and we will catch you on the next one.